Everything in your body is made out of cells. These cells are made out of molecules, which they are made out of atoms. But the scale won't stop there, because the atom itself is made out of particles. In conclusion, everything in the world is either different types of particles or packets of energy. But where did these different types of particles come from? And why some particles don't exist in our environment as much as electrons and quarks? Well, we'll talk about it now. This great and vast cosmos, with all the massive structure and complexes, is made and ruled by 12 particles and 4 forces. These 4 forces are gravity, strong nuclear force, weak nuclear force, and electromagnetism. Except gravity, the other 3 forces can be found in the particles table. The particles table is a table that illustrates all the different particles that exist in the universe. The table is divided into leptons, quarks, and bosons. In the bosons, we can see how the 3 forces are represented. The gluon here is responsible for the strong nuclear force and holds the atom structure. The photon is responsible for the electromagnetic force, and boson Z and boson W are responsible for the weak nuclear force. As we mentioned in the previous video, all these forces used to be united in one force called the superforce, which in time, one by one, all these forces got separated from each other. The last force to be separated was called the electroweak force, which is our topic for today. But before we begin, we must explain the weak nuclear force. Quick question. What is the difference between a proton and a neutron? Well, you might say that one of them is positively charged and the other one is absent. But in order to see the actual difference, we must dig deeply inside the particle. Inside a proton, for example, there are 3 quarks connected by the massless particle gluon, as we mentioned before. The difference between a proton and a neutron is that the quarks inside the proton are divided into 2 up quarks and 1 down quark, while neutron has 2 down quarks and 1 up quark. They are not formed and created separately, and the changes that occurs to the quarks can turn them into each other. For example, if a neutron was unstable for a period of time and hasn't been interacted by another atom, one of its down quarks will release energy in the form of negative boson W, turning itself into an up quark, which in this case will be called a proton. After that, the negative boson W will decay into an electron and an antineutrino. This process does not only take place with a neutron, but it also occurs to the proton. This process is so great and important because the weak nuclear force is responsible for the certain types of radioactive decay, such as beta decay. It also causes a nuclear fusion of neutron and protons to form a deuteron. However, the weak nuclear force is not creating new particles because it's not forming them from nothing. Rather, they are meditated through interactions between particles that already exist. Now, let's talk a little bit about the electroweak force. In the early universe, at a temperature higher than 100 trillion degrees, a unification occurred between the electromagnetic force that is responsible for light behavior in the universe and the weak nuclear force that is responsible for the radiation in the atomic process. This unification created a force called the electroweak force that was discovered in the 60s by Steven Weinberg and Sheldon Glashow. Not discovered obviously, but they reached the conclusion of its previous existence. In high energy states, electromagnetism and weak nuclear force are indistinguishable, and they are both described as a single force in the universe. Why these 2 forces got separated in the first place? Well, the reason lies in the nature of the particles that rules these 2 forces. Photon is a massless particle with the highest movement velocity in the universe, while boson Z and W are one of the most massive particles and the particles table. Boson W has a mass of 80.39 megaelectrovolt and boson Z has a mass of 91.18 megaelectrovolts of mass. Electrovolt is a mass measurement unit for the particle that was created by Albert Einstein. Today, we gave a summarized explanation for the electroweak force, and we also gave most of our time on understanding the weak nuclear force. Hopefully in the future, we'll talk about the electromagnetic force more broadly. But until that day, do not stop wondering and be curious.